Hello, hello. Mr. Lee here. All right, so this practice is going to put all your function transformations together. Okay, so we could have two transformations happening at once, we could have three, um, but we're still going to use this same chart, okay, to see which transformations we're incorporating and how it changes the equation. Okay, all right, so here's the setup. G is a transformation of f, so make sure you know your order. F is the original, which is in blue. The final, after the transformation, will then be the dashed function in red, which is g. Okay, so f to g. It's asking what's the formula of g in terms of f. Okay, so we're starting at f of x. We're going to apply some transformations, which changes the function notation a bit, and then we'll see which one matches. All right, so we're going to go down the line. This is multiple choice. We're going to start at A, go all the way down to D. If we find the right answer, then we're good. If we don't, we're just going to keep working down the line. But either way, you'll have some learning opportunities to see how a lot of these reference points move based off the transformation. Okay? All right, so let me get a marker ready here. Okay, so f of 2x, that's going to match with your horizontal stretching and compressing, right? All that changes is we're incorporating a 2 inside the function in front of x. So your b value is 2. Okay, we're starting off with, my opinion, the more complicated transformation. Because if you remember, if your b value is 2 for a horizontal stretch or compression, you have to take the reciprocal, right? Take the reciprocal to figure out the scale factor. So your b value is 2. That means your b value is bigger than 1. And then flip the 2, right? Flip it. You get 1/2. It's a compression of 1/2. Okay? So all of your x values are going to horizontally compress by 1/2. Okay, so let's get a reference point here. This looks like a good one. It's about at -6. Okay, if I'm saying it's a horizontal compression of 1/2, take your -6 divided by 2, you get a -3. Already, that's wrong, right? You could use this reference point too. Divided by 2, you get closer to the x-axis, or closer to the y-axis, like right there. Still wrong, okay? So from F to G, it's not going to be a horizontal compression, right? These points prove it. So let's move on to the next option. Okay, I'll still use this as a reference point, so I'll keep that there. Actually, better yet, I think let's use this one. Okay, just because it's a nicer point. It's at 1, 1. All right, so option B, 1/2 f of x. 1/2 is in front of the function, okay? So we're looking at an a value now. We're looking at a vertical stretch compression, which probably has a better chance because we found in option A the horizontal didn't work at all. Okay, so 1/2 on the outside. A value is 1/2. Keep checking your chart, right? Your a value is in between 0 and 1, right? Your vertical stretching and compressing is more straightforward. Your 1/2 scale factor matches the a value, so this is going to be a vertical compression of 1/2. So I'm going to take this y value, right? If we're looking at the vertical component, the y value is 1. I'm going to compress it by 1/2. 1 divided by 2, or 1 times 1/2 is just 1/2, so I'm going to have a final y value there. That clearly does not touch the g function either, so we can move on. That's a wrong answer. Okay? So option C, vertical compression, vertical stretch this time, because we have an a value of 2. Keep checking your chart. A value is 2. A value is bigger than 1. We're going to stretch it by 2. This looks promising, right? Take that y value of 1, multiply it by 2. Boop, right there. Okay? We do need to get some extra reference points just to make sure, right? We've matched 1 point, but it's possible that we have other transformations going on. So we want to be doubly sure. Let's go back to this point. Okay, so it's about a y value of 4. If you keep the x value the same, multiply by 2, you get a y value of 8. That looks like we're good. Okay, here's another reference point. You're on the x-axis, right? Which is a y value of 0. Take 0, times it by 2, you're still at 0. So it makes sense that f and g have the same x-intercept here. Okay, so there we go. We're not going to test D because we found the right answer. Let's do some more here. All right, so same setup. G is the transformation of F. F is the start. G is the final. So the reference point I'm going to use, let's use this local max right here. Okay, so I'm talking about this guy right here, 3, 1. Okay, F is the original. Let's go through each of these. So option A, F of 2x. I love practicing the horizontal stretches and compressions because by far, like I've been saying, they're the more complicated ones. So my B value is 2. Okay, keep checking your chart. B value is 2 at the very bottom of our chart here. B value is 2. That means it's greater than 1. Take the reciprocal, flip it, right? The reciprocal of 2 is going to be 1/2. So we're actually horizontally compressing by 1/2. Okay, so let's see if that does the trick. We're focusing on the x values being cut in 1/2. This is an x value of 3. 3 divided by 2 is going to be 1.5. So that looks pretty good. Let's keep checking all the other reference points. I have a reference point here. This is about an x value of -4. Okay, it's a little bit off of -4, but it's pretty close. We can use it as an estimation. -4 divided by 2 is a -2. That looks good, right? Focus on the horizontal nature of it. Let's see if this x-intercept makes sense. So I know it's not a nice number, but it's about -6.5. Check with the calculator if you need to. Divided by 2, it's going to be a little bit bigger than -3 point something, right? So that definitely matches. It's definitely compressing by 1/2 altogether. We found our right answer already. Okay, so it's a horizontal compression by a factor of 1/2. The B value started at 2. Okay, we have a parabola here. I like to use the vertex as your reference point. I'm going to start here and see what we do. We could probably look at this and just be like, oh, it's going left 2, right, to get to that vertex. So F to G, blue to red, goes left 2. Okay, so this one we can just talk about. I think translations are a little bit easier to talk about. Option A goes up 2. We don't want that. Option B goes right 2. Option B goes left 2. We want that one. Okay, and then option D goes down 2. So C is what we wanted. Right? F to G, left 2. Okay, this one doesn't look like it's stretching at all, and based off the answer choices, we're just looking at translations. So I guess we're ending on some easier ones, but that's not to say you can get harder combinations. So I'll still go this point by point. We do have a cubic. So good reference points to pick would be probably this local max and this local min. Okay. And remember, every point has to move with the transformation that's being described. So let's see what option A gives us. F of x minus 1. F of x minus 1, you're inside the function, right? Keep checking your chart if you need to. That should be a translation to the right one. Okay, so that means each of these would go right 1. That's definitely not what we want. Okay, G is not even close to those new points. Option B, we go down 1, right? We're on the outside of the function, -1, so that would be these 2 new points. That's no good either. So hopefully we can figure out that it definitely has to be option C. We're going up 1 each, right? Every point on F goes up 1. That definitely matches now. So we found it, option C. All right.